In this series of videos, we are going to see how we can visualize data and create a narrative around the data using a very popular data visualization tool called Tableau. What you're seeing right now is the opening screen of the Tableau desktop public, which you need to install on your laptops or desktops in order to do this exercise. The place where you can get the Tableau public desktop is this link. I'll put this link in the description of the video. You can download Tableau public from here. Tableau public desktop is completely free. There are other versions of Tableau which are paid version. However, for training purpose, I would recommend that you use the free version only. We'd also need to create an account in public.tableau.com, the portal that you see over here. I'll post the link of this as well in the description of the video. This will be required for publishing your work. That means the charts that you create in Tableau desktop. Uh, in the Tableau public desktop version, you cannot download a chart in your local machine. So we have to publish it in this portal. However, if you have an enterprise edition of Tableau, you do not need to publish your work in the portals. We will use, for the purpose of the exercise, a very popular dataset called sample superstore dataset. This dataset is also available in the community portal of Tableau. This is the link to the portal. I'll give it in the description of the video. You can download the dataset of sample superstore from this. Before we start visualizing any data, the most important thing is to understand the data. Hence, what we are going to do now is we are going to open this simple data set in Excel and see what the data means. And then only it will be useful for us to proceed with the visualization. So let us now open the data set. The data set that you have downloaded might vary slightly from the data set that I am using, because sometimes the data sets gets updated. However, there should not be any big difference between what I'm using and what you have downloaded. So let us see the data set. So this is the sample superstore data which we are going to use. It has only one sheet. In case the Excel file that you have downloaded contains more than one sheet, please keep the sheet which contains the data that you see over here. You can delete the other sheets. We do not need those for the purpose of this exercise. If you see the data, the first thing that you should look at is are the columns that are there in the data. For example, in this data, you have the customer column, which contains the names of the customer name, segment, country, city, state, etc. And if you go down below, we'll also see columns of sales, quantity, discount, and profit. So essentially, every row of this particular data talks about one sale that has happened from this particular fictitious superstore. If you look at the type of columns that you see over here, you will see that there are primarily two different types of columns, which technically we call as fields or attributes. One type of column consists of certain categorical values. For example, customer name, or segment, or shipping mode. So these are not quantitative values. These can take certain possible values, or even city, state, etc. Whereas if you look at the fields of sales, quantity, discount, and profit, they are numeric values. So the fields, though, which are consisting of categorical values or non-numeric values, for the purpose of data visualization, we call them as dimensions. And the ones that contain numeric values, we call them as measures. Now, this is a very, very important concept that you must understand, because as we go along, this is going to play a very big role in determining what kind of charts you are going to make. So if you look at this data set, essentially you will see that the four fields of sales, quantity, discount, and profit, these are the measures, and most of the other fields are dimensions. Why did I say most of the other fields and not all the other fields? It is because certain fields, while certain fields, it is very clear that they are categorical values, they are dimensions like customer name, segment, country, etc. There may be some fields where we are not very sure whether they are dimensions or measures. An example can be date field. So here you see there are two dates, order date and ship date. Now, why are we saying a date field is not, we cannot be very sure whether it's a dimension field or a measure field? Normally, the purpose of dimension and measure is that when you are making a chart, you essentially try to aggregate all the values. That is where the value of any chart lies. If I look at this entire sheet of rows and columns, it hardly tells me anything. But when I am going to aggregate it, I am going to get some insights out of it. In order to aggregate any data, you must know the measure that you want to aggregate. For example, whether you want to aggregate sales or whether you want to aggregate profit, etc. And the dimension against which you want to aggregate that. For example, I may say that I want to aggregate sales by country or sales by city. Or I may want to say I want to aggregate profit by segment. So there's a measure, sales or profit, and I'm aggregating it by a dimension, a country or a state or a city or a customer, etc. All charts that you make essentially will be an aggregate of a measure against a dimension. So essentially, you can have mathematical operations on the measures because they're numeric values and you need to aggregate them. Whereas usually for dimensions, no mathematical operations are possible. However, there may be certain fields like the date field where in certain instance, you may not need to do any mathematical operation. In other instances, you may need to do a mathematical operation. For example, if I want to aggregate sales by date, here date will not be used for any mathematical operation. The aggregation will be on sales, which is a measure. So in this particular case, date will act as a dimension and not a measure. However, if I want to find out the number of days between the order date and the ship date, which we may call as a lead time to ship, in that case, I have to subtract the number of days from the ship date to the. In that situation, I am using the date for a mathematical operation. In such a situation, date will be a measure. So, while in most of the cases, the dimensions and measures are clearly identifiable, in some cases, dimensions and measures are depends on the use of that particular chart. What we are now going to do, we are going to import this data into Tableau, and then we'll start analyzing the data in Tableau and then visualize that. So let us import the data into Tableau. In order to import the data into Tableau, you have to come to this particular screen, which is the opening screen. And these are the types of files that you can import in Tableau Public. In the Tableau Enterprise version, there are a lot of other options available from where you can import the file. And usually in the enterprise scenario, you will be required to import large data sets that may be residing in an ERP system or that residing in some other relational database system or even data from the web. However, for the public version, we only have these options to retrieve the data. And for our exercise, we are going to use an Excel file. So when you click on the Excel file, it will ask you to select the folder from where you are going to upload. So whichever folder you have saved your sample superstore, go to that folder and select the file that you need to upload. Once you have selected the file which you want to upload, in our case, it is the samples to superstore file, you will be landing into this particular view. If you analyze this view, it consists of three panes. The top pane essentially consists of the sheet that you want to use. In our case, the Excel has only one sheet. If your Excel has more than one sheet, this will be empty and you have to drag and drop the sheet that you need to use in this particular empty space before you can see the data below. That's why I mentioned that in your case, to make things simple to start with, just keep one sheet so that you don't have to do that exercise. Later on in subsequent videos, when we see how to use multiple sheets and how to use more complicated functions like joining of different sheets or rather tables, uh, in that situation, you see how to use drag multiple sheets and how to create joins between them. For now, we'll continue with one sheet, which essentially is one table. So I'm using the term sheet and table alternatively because in Excel, it is a sheet, but if you look at from a database perspective, it is actually a table. Down below, what it has done is it has taken the fields. So it shows the fields in your table. And it also indicates the data type of the fields. For example, the row ID data type is number, the order ID is the text field, dates, order date and ship date are date fields. So if you go over here, you will and click over here, you will see the type of data that Tableau has selected. Now you must have noticed by now that Tableau is intelligent enough to identify which is the possible data type. In case Tableau has not identified correctly, you can always change the data type from here. So if you go down below, there are some other interesting data types like country, city. If you notice, these data types have a symbol of a globe, which means that these data types are actually a geographical data type. Now, while it shows string, if you go down and see the geographical role, it shows the country or region. Now, these are very important because later on when we try to visualize the data on a map, it's necessary that these data types, which are geographical elements, are defined as geographical data types. In case, for some reason, in your case, it has not been defined in the same way, you must change this to the right geographical data type. For example, for country, it should be country. For city, it should be city. And down below, the state, the geographical role is state or province, and your postal code, where the geographical role is zip or postcode. You would have probably noticed there's another geographical type of geographical unit called region, but it is not shown as a geographical unit, it is shown as a region, shown as a text. So this is a text or a string. The reason is very simple. Region is not a standardized geographical entity. So if I say north of US or north of India, it may constitute of different states as per the definition of the user. Different companies may have their own definition of north of US or north of India. That is why region is not a standardized geographical entity, whereas city, state, postal code, country, etc. are standardized geographical entities. And if you see the measures over here, sales, quantity, discount, profit, etc., these have been defined as numbers. So for our case, Tableau has taken the data types correctly, so we don't need to change anything. In case for you there is some difference, you should change it to these data types. On the right hand side, it shows a sample set of data that is imported. This is just for you to check that the data has got imported correctly, and you can check this with the original data that you have. For us, it looks that the data has been imported correctly. So we are more or less ready with the data that we want to visualize. In more complex examples, this data might require some pre-processing. You may have to, as I said, join multiple tables, create some new fields, etc. But for this exercise to start with, we are keeping things simple and we are not going to change any data or pre-process any data from here. We are going to directly use for the purpose of visualization. Now let us start our visualization. If you look at it, the next tab is a sheet. So all the charts that you make will be in each of these sheets. In case of Tableau, one sheet can contain only one chart. What is the anatomy of the sheet? If you look at the sheet, on the top right hand corner under the show me, you see there are some faintly visible set of charts. These are the base charts that Tableau provides. So there are 24 base charts that Tableau provides. What is the meaning of a base chart? A base chart means the chart from where other charts can be built by configuring Tableau. One of the interesting things about Tableau is highly configurable. You can create other charts from the base charts by configuring certain values and doing certain calculations. As we go along, we'll see more of these examples of how a chart can be configured. But initially, we'll start with these 24 basic charts and what they do. On the top, you have the rows and the columns. Unlike Excel, where you need to create a pivot table to summarize a table and then create charts from the pivot table in most of the cases, in Tableau, you don't need to do that. Once you define what are the values that you need to depict as a chart, pivot tables automatically be created by Tableau internally. And those values means whether it's a dimension or measure will be put in the columns and rows. On the left hand side, if you see, all the fields have been imported over here. And if you notice carefully, there is a slight difference in the colors of the two types of fields. One is turquoise blue and the other is light green. And if you notice carefully, the light green ones are the measures and the turquoise blue ones are the dimensions. Now, this is what Tableau has understood. Now, if you want or some dimension to be actually a measure, or if you feel that Tableau has not classified it correctly, then you can always drag and drop a dimension into a measure or vice versa. But in our case, that's not required because Tableau has identified them mostly correctly. We'll also see there are few calculated or automatically generated dimensions and measures like measure names, latitude, longitude, then measure values. So we did not give this. These were not there in our original set of fields. Tableau has calculated automatically because it will be needed for visualization. Now, we as users don't need to worry about these fields. We don't need to directly use them. If Tableau fields is required to be used, Tableau will automatically modify our other parameters and accommodate these measures to create those charts. We'll see how it is done, but we don't need to really worry about what to do with this automatically generated the fields. The most interesting part and the unique part of Tableau is this marks. Marks plays the role of providing additional dimensions to charts in the form of colors, in the form of size. We'll see this interesting part as we draw the charts, but a good Tableau developer needs to understand how these marks work. Now, there's no one formula. As you start using Tableau, you will understand the utility of these marks and where marks should be used. Then you have something called filters, which is used for filtering certain data from the original data. We will see the use of it as we go along. And there's something called pages. At this point of time, do not worry about the pages. We'll see some utility of pages in some of our subsequent videos. So this is the overall anatomy of how Tableau is. As I said that each chart, uh, uh, each sheet consists of only one chart. Now, many times when you want to give a narrative, you want to put multiple charts in one sheet, though it is never a good idea to put too many charts. Usually, not more than 4 charts should be put in one sheet. In order to do that, you create something called a dashboard. So, multiple charts can be combined into a dashboard. Our first objective is to learn what each of these base charts do, and then start creating a narrative from these charts and putting that into a dashboard. We are going to now see how to start with some basic charts in